All right, we are looking at semester exam quiz number 3. All right, this is our third review set of review problems to get ready for our fall semester exam. All right, so we're looking at question number 1, which best lengths side lengths AD and CD given this information. Okay, I recreated the figure over here with the information included. AB is congruent to CB, so I put two little markers right there. Angle DBC, so that'd be this angle right down here, is an acute angle, so it's less than 90 degrees. All right, less than 90 degrees. That is an acute angle. Now, what we have right here really is two separate triangles, right? This big triangle, ADC, has been split by this line going through the middle, and it's been split into two triangles. Now, these two triangles have two congruent sides. Okay, I know there's only one marked. There's only one marked right there and right there, but you also have to recognize that this one that they share, that they have in common, is another congruent side. All right? So the only thing that's different that we know about between these two triangles, we've got two congruent sides, but this angle right down here is not congruent. Okay? Here's the reason we know that. Going right across the bottom, we have a straight line segment going across the bottom right here. And the only way for these two angles to coexist and make a straight line across the bottom, if this one is less than 90 degrees, if this one is acute, this one has to be more than 90 degrees, okay? Those two angles right there next to each other, the red one plus the green one, the only way for that to work is if they add up to 180 degrees. And if this one right here is less than 90, then this one has to be greater than 90 degrees. The only way that would work is if this one is obtuse and this one is acute. That's just like it told us. Okay, so here's what we've got. These two sides of the two triangles are the same, but this third side couldn't possibly be the same. Because if all three sides are the same, that means the triangles are exactly congruent. And that's not possible because these two angles, it already said, we can't have these two angles being the same thing. So AD equals CD? Not possible. Here's the deal though. This angle right here is larger than this one right here. And if these two lengths are the same, the only way for this one to be larger is if AD is a longer side than CD. So that's what we're going with. This answer choice right here. AD is greater than CD. Go on to our next one. Question number 2. This is a question about logic. This question is asking us, what can you conclude from the given statements? Okay, the only two statements that we have that are related to snow and school are: if it is snowing, then school will be canceled. Okay, if it is snowing, that implies school will be canceled. The second statement: it is snowing. Okay, now any of these things may be true. School will continue as normal. That's possible. School will be delayed. That's also possible. It will not snow tomorrow. That is also possible. But we don't know for sure. The only thing we know for sure is this statement right here. If it is snowing, school will be canceled. So it is snowing. The only conclusion we can draw from that, the only assumption we can make from that statement alone is school will be canceled. Question number 3. Which of these side lengths does not make a triangle? We have to use the triangle inequality. Y'all may remember that from when we took those extra notes on it. The triangle inequality looks like this. Nope, not equals. A plus B is greater than C. Okay, that's when you have a triangle and your side lengths are A and B and C. If you take your two smallest sides and add them together, it has to be more than the third side. Okay, it can't be equal to, it can't be less than, it has to be more. So look at your answer choices. Your two smallest ones on this first answer choice are 3 and 11. Well, 3 plus 11 is 14. 14 is more than 11. So that means this one does make a triangle. That one works with this inequality. So it's not going to be our answer choice. We're looking for the one that does not work, does not make a triangle. Up next, 3, 4, and 6. 3 plus 4 is 7. 7 is more than 6. So that one's not going to be our answer choice. 3 plus 8, our two smallest ones. 3 plus 8 is 11. 11 is not more than 12. So that one right there would not make a triangle. Go ahead and check your last answer just to be sure. 8 plus 12 is 20. 20 is more than 19. So it's going to be this one right here. All right, 3, 8, and 12, that could not be a triangle. That one's going to be our answer. Question number 4. Which postulate or theorem can be used to prove the triangles are congruent? Or maybe it's not possible, and that's what you would choose. You choose not possible or not enough information. NEI, that would be your answer. Okay, so here's what we're looking at. I'm going to try and recreate this figure right here so we can add stuff to it. This is a very similar picture to what we had on one of our previous ones from exam quiz number 2. Okay, we had two triangles that were given to us in kind of a similar arrangement to this. But again, just like we had on that other one, we run into the same problem. Right there in the middle of this picture, right in here, we've got two straight lines across each other, and it's never going to be marked. That's what I've been saying this whole time. It's never going to be marked. You have to recognize for yourself that in the middle of that picture, you have opposite angles. And opposite angles are congruent right there and right there. All right, I'm going to give it 3 markings because we've already got 1 marking and 2 markings on there. Okay, those two in the middle are also congruent to each other. Now, what we have here is angle, angle, angle. There are no congruent markers on any of the sides of these two triangles. Angle, 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 if you'll remember back to those topic 3 notes, and you can look through those as you're going through, angle, angle, angle does not prove congruence. Angle, angle, angle doesn't do anything. Y'all remember the animation that we showed where you could take a triangle and shrink it down and it would still have all the same angles, okay? Like if we drew a triangle that was up like that and another triangle that was up like that, all of the angles right down there in the very, very corner are the same. But clearly these two triangles are not congruent. They have all the same angles, but they're not congruent to each other because they're not also the same size. All right? So this right here, when you have 3 angles all matching, that is not enough information to say if they're congruent. NEI, not enough information. Go on to our next one. Which postulate or theorem can be used to prove triangles are congruent? All right, this is so we already talked about the questions like that previous one where you've got opposite angles in the middle. On a picture like this, we've got angles right there. We've got sides. Sides right there and there. We already talked about how you have to recognize opposite angles. A picture like this is the other thing you have to recognize. Okay? When you have a line that cuts through the middle of your shape and it splits it into 2 triangles, you have to realize that that line is a third congruent side. Okay, I'm going to highlight it to show you that right there, you have to be able to recognize is a congruent side for both of those triangles. So we have a side, an angle, and a side that are congruent between both of those triangles. Side, angle, and side. That's SAS congruence. Last question on this quiz. Is the same thing. Which postulate or theorem works for this to prove the triangles are congruent? All right, again, we've got a shape that is split into 2 triangles. Let me make this picture match the one on there. Those are right triangles. You can tell by the little box in the corner that those are right triangles. And what we have is one side right there, and we've got another side right across here. Now here's the weird thing, okay? This is right triangles. Okay, you can tell by the box in the corner that these are right triangles. If you count this side as one of your congruent sides, you need to recognize that that is the hypotenuse of the triangle. And this other side that's marked on the left side, on the left of your picture and the right of your picture, the other sides of these triangles that are marked, those are legs. Okay, we have the hypotenuse of the triangle, and we have one leg of the triangle that matches each other. That is HL. That's that weird one. All right, so that's all we've got for exam quiz number 3. We'll come at you again another time with exam quiz number 4, and we'll finish up later on with exam quiz number 5. All right, y'all have a good one.